Hi everyone, in this video we're going to cover section 3.3c, which is going to connect knowledge that we know about f and f double prime, and we're going to connect it back to what the graph of f would look like, or at least what different features of the graph of f would be. So this video is spliced from some previous ones, so enjoy.
So on this page, we're going to put together ideas from the past, few previous pages. So we're going to talk first derivative, we're going to talk second derivative, concavity, mins and maxes, the whole shebang. So pause the video for a second. I want you to read through all of the information within the question. Pause the video, read over it. Okay, hopefully you've had a second to read through all of that. Before we get started, I'm just going to draw myself just a grid. Okay, I can see here that we have a domain of -3 to 3. And I see that here, looking at these values, I have a range of -1 to 2. I'm going to give myself just a little bit more room with that, a couple extra ticks, just so I have more than enough space. All right, there we go. Okay, so let's see what criteria we have. So first, we're told that our function is even. So if you remember back from pre-calc last year, an even function is when we have a reflection over the y-axis. So we have nice symmetry over our y-axis. So that's helpful to us because I see that within this table, we're only given information from 0 to 2, right? Only these values over here. But because we know it's even, okay, we automatically know some stuff from, on the other side. So I'm just going to add to this table just so we have more information. We know that when x is -1, our y value is 0. And when x is -2, we know our y value is -1. Cool, okay, that's helpful. We also know that our function is continuous, so we shouldn't have any sort of discontinuities. We don't have any jumps, we don't have any asymptotes, nothing like that. It's going to be continuous. All right, so looking through this, I'm just going to go through, I'm going to graph the points that I've been given from this table. So I know that at -2, we have a y value of -1. At -1, we're at 0. At 0, we're at 2. At 1, we're at 0. And at 2, we're at -1. Yeah, close enough. Now I'm going to fix it. I can't let myself settle for mediocrity. Okay, there we are. Okay, now we kind of need to know where to go from here. So one thing that I notice, checking out this table, okay, we're given our values of f, then we're told information at certain points about our first and second derivative. So I can see here that at 0, our derivative doesn't exist, and at 2, our derivative doesn't exist. So I know that our function is continuous, so that means that I'm going to have some sort of like sharp turn or cusp. Meaning that our slopes, don't match each other or limit, on either side, but we're still going to have a continuous function. So that's just one thing to keep in mind. Another thing that I might do, looking at this table down here, I'm going to label what each row is telling me. So it's giving us information in some intervals. So from our interval 0 to 1, okay, f is positive, so that's talking about what our y values are. Okay, in this table, given information about f prime, okay, well, let's think, what does f prime tell me about the function? Well, that tells me about our slope. So here, I know in this interval, our slopes are negative. Slopes are negative in this interval. But, okay, here we go. In this interval, our slopes are positive. Cool. And then, okay, what does our second derivative tell me about the function? Okay, that tells me about concavity. So because we're positive here with a second derivative, that means that we are concave up. Concave down, since we're negative, here and here. All right, with this information, I'm going to focus in on this table, and we'll come back and double check information from here. But this tells me a whole lot. So I know that between 0 and 1, so this interval, I know my y values are positive. that makes sense. So I'm not going to dip and then come back up. I know that my slopes are going to decrease. So I know that we're just going to be decreasing the whole time. We're not going to decrease and then increase and decrease. And I know this whole time we're concave up. So we're not going to go concave up, concave down, nothing like that. So here, making sure my y values are positive, slope negative the whole time, and concave up, we might look like this. Okay. Next interval from 1 to 2, my y values are going to be negative the whole time. We'll have negative slope the whole time, and the whole time we're going to be concave down. So we're going to look like this. Okay, so at this point 1, I see, okay, y value is 0. We got that. I know here it kind of looks like our cubic function. Kind of looks like I have a horizontal tangent here. So our first derivative is 0 and second derivative is 0. Okay, we nailed it there. Let's talk about what's going on between 2 and 3 now. So I know that at 2, our derivative is not going to exist. We're going to have a cusp or a sharp turn. I see my y values on this interval are going to be negative. So I'm not going to, dip up and down. I'm just going to stay down. I know that our slopes are now going to increase. That's good. And I know that we are going to be concave down the whole time. So in this interval, I might have something that looks like this. So I'm going to have some sort of y value needs to stay negative, but here we are. So I see that at 2, just like our table told us, our derivative doesn't exist. Okay, and then since I have all of this information filled out here, well, hey, neat. I know that I can just reflect all of that over the y-axis. So let's just double check what's happening at 0. Okay, at 0, y value is 2. And then at 0, again, our first derivative isn't going to exist. We have a cusp here. All right. Nailed that. So let's go down below and we're going to determine the coordinates of any local extrema and of any inflection points. I want you to pause the video. I want you to try that for yourself. We'll chat in just a moment. All right, hopefully you've had a second to try that on your own. So let's see. Okay, we have a local max of 2 when x equals 0. And, okay, I'm going to reference the first derivative here. So I knew that because f prime was changing from positive to negative at that point. So meaning that our slope went from positive to negative around there. Okay, we had a local min of -1, and that occurred at 2 places. That occurred at x equals 2 and x equals -2. Because our slopes went from negative to positive around that point. Okay, because we're also talking about, mins and maxes, we also had some local maximums that occurred at endpoints. Remember to take those endpoints into consideration. So we had a local max of x equals 3, and I'm not going to state our y value because we had some choice as to where those y values were. So I'm just going to say we had a local max of x equals 3. A local max at x equals 3 because our derivative over here, our derivative was positive to the left. So I know we were increasing, and then we got to the endpoint. And then we had a local max at x equals -3, and kind of for the same reason. F prime to the right of it was decreasing. Then, so remember, take your endpoints into consideration. It's easy to forget about them because we're so focused on those critical values. Okay, and then our points of inflection. So we had 2 of those. We had a point of inflection at x equals -1, and we had a point of inflection at x equals 1. So here and here. And we knew we had a point of inflection because our second derivative was changing sign. So we don't need to say it went from positive to negative or negative to positive. All I need to say is it changed sign. And you might be wondering, okay, well, where the heck can we see where it changes sign? Let's look at these intervals. I knew that at x equals 1, we went from positive to negative, changed sign. And because this was an even function, it was also occurring at -1, same thing. We have one example, example 4. It's going to span the next 2 pages. We're going to look at the graph of f prime, So this is an f, this is f prime. And we're going to answer a whole lot of questions about the graph of f. So one thing to note is our function f is continuous, it's twice differentiable, and it exists over the interval -5 to 5, the closed interval. That's important. So first, we're going to look to see where f is increasing and where f is decreasing, and we'll justify our answer. So whenever I see increasing, decreasing, I know that's really talking about the slope. We're looking to see where the slope of f is positive and the slope of f is negative. Okay, well, we know that the graph of f prime really is a graph that tells us what the value of the slope is at any certain point. So if we want to see where our slope or where f is increasing, we need to look to see where f prime is positive. And that's going to be everywhere that it's greater or above the x-axis. So I see that it's above the x-axis from here, all the way up to here, and then down to here, and then we're greater or above the x-axis over here. So I'm going to say that we are increasing on, and I like to define increasing, decreasing on the open interval. Now I know that there's a corollary that says that we can define it at points as well, just because increasing, decreasing doesn't occur at a point, it occurs on an interval, so there really is no harm in including points. I just prefer to define it on the open interval. So we are increasing on the interval -5 to -3, and then from -3 to 1. So before I go on any further, you'll notice that I skipped it at 3. Well, that's because that's saying that our slope is 0. We're really not increasing there, right? Our slope isn't positive, it's not negative, it's 0. I'm choosing to skip over that. So I have those intervals, and then we're also increasing from 4 to 5. So even though our graph kind of cuts off, I know that it really keeps on going up until we get to 5. It also tells us to justify our answer, so let's think, how do we know that f is increasing or decreasing there? Well, it's because that we knew our slope was positive. So because I can either say this as f prime of x is greater than 0, or I could also say because f prime is positive. And then it wants us to find decreasing, so okay, we're going to be decreasing wherever it's below the x-axis. So from 1 to 4. And we knew that it was decreasing there because either f prime of x is less than 0, or because f prime is negative. So either one really works there. All right, okay, for B, we're going to find any x values that correspond to any extreme values of f, and then we'll discuss if they describe a max, a min, or neither. So remember, I'm going to scroll, when we are talking about extrema, there are places that we are looking for that. So we're looking to see where the derivative is equal to 0, where the derivative is undefined or doesn't exist, and we're checking endpoints. Okay, I see on our graph of f prime here, there's no places where the derivative doesn't exist, so that kind of takes that one out. But there are quite a few places where f prime is equal to 0. For instance, -3. We have 1, and we have 4. So, and we also have our endpoints. That's important also. We have an endpoint at -5, and we have an endpoint at 5. So we have 5 potential extreme values. But it is important, especially for where the derivative is 0 or undefined, we have to make sure that they change sign. And remember, the reason that we're making sure that it changes sign is because that tells us, okay, our slope was going from increasing to decreasing, or our slope was positive to negative, or our slope was negative, positive, so that tells me that that's where it's changing. So, coming down below, let's look at our first potential extreme value. That was x equals -3. Well, okay, if I'm checking the value, the sign of f around it, I see that to the left, f prime is positive, and to the right, f prime is positive. So because we don't actually change sign at -3, that tells me this is not an extreme value. So I'm going to say that x equals -3 is not an extreme value. And that's because f prime doesn't change sign. So this could potentially be a shelf point here. We're increasing, we kind of plateau off, and then we increase again. If we look at x equals 1, let's see. I see that f prime to the left is positive, and to the right, f prime is negative. So that's telling me, okay, we had a positive slope, we got to x equals 1, and then we had a negative slope. So I know that x equals 1 is going to be a max. And I know that this isn't, we don't have any information about the y values, so I can't make a statement to say that this is an absolute max, so I can only say that it's a local max. And we're going to state why. We knew because f prime went from positive to negative. Oops, that's a positive. Okay, now let's look at 4. This was supposed to be an arrow. I don't know if I wrote 4 there, but okay, this is an arrow. So at 4, let's see, to the left we are negative, to the right we're positive. So meaning that we had a negative slope, we got to 4, and then we had a positive slope. So x equals 4 is going to be a min. Okay, so we have our 3 extreme values, but remember we also have to include endpoints. So let's see what we can say about our 2 endpoints. So looking at -5, I see that to the right of it, we are increasing. Our slope is increasing because f prime is positive. So meaning, okay, I had my endpoint, and then to the right, I have a positive slope. So that means that x equals -5 is going to be a local minimum. Now, okay, when we justify it, we have to say a couple things. We need to say that it's either a left or right endpoint, and then we need to say what f prime, what the sign of f prime was to the right or left. So this was a left endpoint. Left endpoint. And let's see, f prime was positive to the right. Okay, and then we have one more endpoint over here. Let's see, so I have my endpoint. I know that to the left of it, we are positive as well. So that means that we had a left endpoint, and then we were, so here's our left endpoint. And then to the left of it, we had a positive slope. So that means that this is going to be a local max. All right, okay, and this was a right endpoint this time? Okay. So when in doubt, you'll notice here that I always draw pictures. So I really think to myself, hey, okay, f prime is telling me about the slope. So what does the slope mean for f? So I always draw pictures, and you'll always see me do that. It at least just helps me kind of visualize it. All right, we're going to flip over to the page. So same example, just some new questions. So now, based on our graph of f prime, we are going to determine where f is concave up and where f is concave down. We'll justify our answer. So, okay, let's think about what we know about concave up. So concavity really tells us, we can define that, I guess, as thinking about the slope of the first derivative. So thinking about the slope's slope. So when we are thinking of concave up, okay, well that's where f prime's slope is increasing. Or we can also think about that as f prime's slope is positive. So if we know concave up is our slope is positive, and here's our graph of f prime, let's see where this graph has positive slope. All right, so I see I have positive slope from -3 to 1, right? And I also have positive slope from 3 all the way up to where 5 would be. Let's see, and that was -1. I feel like I always forget to say the negatives. Hopefully you're catching me in my head. Okay, and then remember concavity is always going to be defined on an open interval, so we don't even have the choice to include our points or not. So if we want to justify it, we know that it is concave up because f double prime is greater than 0. Or we could also use any of these descriptions over here. We could say that f prime slope is positive or f prime slope is increasing. I don't want to write all that out though. All right. Okay, if we want to discuss where f is concave down, okay, well concave down is going to be kind of the opposite. So we're looking to see where f prime's slope is decreasing or where the slope is negative. So, okay, looking at our intervals where we have negative slope, we got negative slope from -5 to -3, and from -1 to 3. And justifying it, that's because that's where f double prime is less than 0. Okay, for D, we're going to talk about where f has any inflection points. So let's think about what we know about inflection points. Let's see, inflection points, close enough. Okay, so inflection points are going to be where f prime slope changes sign. So where does the graph of f prime change from positive slope to negative slope, or negative slope to positive slope? All right, well, it's easy. We can just look at our graph here. We went from decreasing to increasing, so we have an inflection point at -3, point of inflection, if you will. We went from increasing to decreasing here, so we have a point of inflection at -1, and we went from decreasing to increasing, we have a point of inflection at 3. Okay, and because it says to justify our answer, well, we can write basically what we wrote down below. That's where f double prime changes sign, or that's where the slope of f changes sign. All right, lots of writing on here. For our last point, okay, we're looking at E. We have a point for f, so we know that f of -2 is -4. We're going to write the equation of the tangent line of f at x equals -2. Okay, well, tangent line, so that should have you thinking about what we need to write the equation of a line. Well, we need to write we need to have a point, and we need to have some sort of slope. So we can use point slope for it. Well, neat. Okay, they gave us a point, right? We know that we have -2, -4. And where could we figure out the slope of f? Well, good thing we've been given a whole graph that tells us exactly what the slope is at any given x value. So if I want to know the slope at x equals -2, boom, I know that the slope of -2 is going to be 1 because that's what our graph tells us. Slope of -2 will be 1. So f prime of -2 is 1, so that means m is 1. And now we have everything we need. We got our point, we got our slope, let's write our equation. So we'll have y equals 1 times x plus 2 minus 4. And you don't need to simplify it, let's just leave it like this.